Question 14. The giant swing at a country fair consists of a vertical central shaft. This is the central shaft, with the numbers of horizontal arm. This is the horizontal arm. This is what we call horizontal arm. Attached at its upper end. Each arm supports a seat suspended from a cable of 5 meters long. The upper end of the cable fastened to the arm at a point 3 meters from the center shaft. Find the time of one revolution of the swing if the cable supporting a seat make an angle 30 degrees with the vertical. So we want to find the time of one revolution. So time for one revolution is referred to period T, whereby this T we can relate with omega. So in order to solve the question, so we know that these passengers are going to perform uniform circular motion, whereby this is the center of our circle. So I extend this one, then we will get this one will be the radius. This is the radius of the circle. The radius is combination of 3 meters here and also the distance here. This distance can be determined by using 5 sine 30. So 5 sine 30 is equal to 2.5 meters. So the radius of the circle will be 3 plus 2.5 will be 5.5 meters. So in order to solve the question, I am going to apply Newton's second law for the horizontal uniform circular motion. So I have to draw the FBD first. So I'm going to have the tension in the string T and the weight W. So this is the angle theta, whereby the theta for this situation is 30 degrees. So resolve the tension. I'm going to have T sine 30 and here will be T cos 30. Okay, so apply Newton's second law to the horizontal component because we are performing horizontal circular motion. So the T sine 30 will equal to mv squared over r. So I put this one as my first equation because there are too many unknowns. Then I consider the y-axis. Total force along y-axis will be 0 because we do not have any motion along y-axis. So we have T cos 30 minus weight equal to 0. So we have T cos 30 equal to mg. So this will be my second equations. So let us take 1 divided by 2. So I'm going to have T sine 30 equal to mv squared over r divided by T cos 30 equal to mg. So cancel out the m and also the tension. So I'm going to have tangent 30 equal to v squared over rg. So put in the value. So tangent 30 will be v squared over, the radius is 5.5, the g is 9.81. So press the calculator, so I'll get my v is 5.5813 meter per second. So I try to relate the v with the period that I want to determine. So v is r omega and omega is 2 pi over t. So I put it in. So v will be r 2 pi over t. So the v is 5.5813. The radius is 5.5 times 2 pi over t. So when I calculate, I will get the period for This question will be 6.19 seconds. Okay. Then let us see what is the second question. B. Does the angle depends on the weight of the passengers for a given rate of resolutions? So, if we notice from the solution of question A, the m is being cancelled out in the equation. So, our answer for B will be no. Why? Because m is being cancelled out in the equations. We only have the tangent theta only depends on v squared over rg. So theta is independent of mass.